Hello everyone, hope you all are fine and safe. Today we will talk about a topic, the sixth point, that is surface charge distribution may be different at different points. We have to discuss this because it's practically it is applicable in many fields. Let me start with a video. Please look this video. Now here in this video you can see it's a machine where charge is produced, and here it's a conducting teardrop. Actually it's a conductor. One side is sharp edge and another side is not so sharp. It's a charge scoop and this is an electroscope, right? Now what he does is he first produces a charge. Here he touches this and he rotates this axle, and he's what actually is doing is he's making this conductor's charge. Now he is taking the scoop and he is touching at that surface, and now he is touching here, and you can see here electroscope is little bit moving. He's did neutral now. Now again he is doing the same process, but same process, he is touching it, he is charging it. Now with the scoop what he will do is he will touch this part, the sharp edge. The sharp edge he is touching, and again he is bringing here in the electroscope and he is touching. You can see that magnitude is increased. The leaf, the gold leaf magnitude has increased. This has gone this much, and this is from the base. Let me show you this image. I hope you know what is this. This is a famous historical monument, a beautiful monument. Can you see the people who are standing here are they are so small here, and compared to them this height of this monument is this much. Can you imagine how huge this building is? It's so beautiful and it's so huge, and it's standing there from centuries actually. And you know why? Just because of this thing here. Can you see this? There is something here. There is something here. If these are not there, this building would have collapsed many centuries back itself. I'll give you a close look. You can see here this monument. This rod, this is made up of copper. This one, this here, all these are for saving this monument, saving this building. And this copper rod in a particular design is connected with a copper strip here. It goes down and goes to the earth. So whenever lightning, thunder or lightning strikes this monument, so because of this rod, they are attracted, all the charges attracted at this point. This is the enlarged portion of that particular rod of Taj Mahal. See this, here it is sharp, here it is sharp, and here it is sharp here. Can you see this? Now whenever thunder strikes or lightning strikes here, what happens is all the charges, because of the charge of the lightning, actually it is attracted toward this only sharp edges, and through this it goes to the earth, saving the monument. Let me show you one more picture. See this building, because of the lightning, and there is a rod here in this flat or apartment, and it is the lightning is only striking this rod because there is a sharp edge here. It is metallic and the sharp edge, and this collects all the charge and it makes it go down here on the earth, towards the earth. In this way this rod saves this flat or the building. Otherwise, because of the lightning, the building may get so many cracks and it can collapse also, right? Let us come to our topic. Suppose I take a conductor in this fashion, and suppose I charge this, and you will find that the surface charge density at this surface it is minimum, and surface charge density at this point it is maximum, because charge distribution is different. Here the charge distribution is different, and here the charge distribution is different. That is sigma, mathematically sigma equal to q by s, where q is the charge and s is the surface and sigma is the surface charge density. Every conductor is an equipotential volume, 3-dimensional, and rather than just an equipotential surface, 2-dimensional. Okay. Now electrical capacitance, the measure of the ability of a conductor to store charges, is known as capacitance or capacity. Mathematically we can write q is proportional to v, or q equal to cv, where c is the constant of proportionality and is known as capacitance. I can rewrite this as c equal to q by v, and if v equal to 1 volt, then c equal to q, right? So we can define capacitance of a conductor is defined as the charge required to raise its potential through 1 unit. SI unit of capacitance is farad. You have to take care of this. Symbol of capacitor is this one. This is a symbol of a capacitor, and these lines, both the lines are same in size. And if you see this is not a symbol of capacitor, this is a symbol of cell, and this is a symbol of capacitor. These two lines should be, if I draw a line like this, suppose I draw a line like this and I put one arrow here like this, then this is a symbol of variable capacitance, means this capacitance we can change the magnitude of it, otherwise this becomes a constant capacitor, right? Now capacitance is said to be 1 farad when 1 coulomb of charge raises the potential of a conductor by 1 volt. See here, if this will be 1 farad only when this will be 1 coulomb and this will be 1 volt. And also, since 1 coulomb is a big amount of charge, the capacitance will be it is very difficult practically actually, and the range, normally practically the ranges are like millifarad, microfarad, nanofarad and picofarad. Millifarad, you know, 10 to the power minus 3, micro 10 to the power minus 6, and nano 10 to the power minus 9 farad, and picofarad is 10 to the power minus 12. So take care of all these points, make a note of all this, and we will do some numerical based on this, right? Thank you and take care.